So parallelograms, guys, these would include squares, rectangles,
Is that a parallelogram?
rhombi. Is that how you say rhombuses, plural? Rhombuses or rhombi? Okay? And they all have the same area equation. The area of all of these things is base times height. So I think you know that, like for a rectangle or square, you guys have probably done the thing where, and I know you did it on Khan Academy yesterday, where you can just count the boxes for area of the units, right? So 1, 2, 3, 4, 5 base units times 2 height units for a total of 10. Yeah. So this also works for this thing called a parallelogram. Parallelogram, the definition is opposite sides are parallel. Notice if we drew boxes in here, we wouldn't have full boxes. Do you guys notice that? But watch, I want to show you something kind of cool. Let's say we cut this chunk off the parallelogram, this blue chunk. You guys see that blue chunk? Let's say we cut that blue chunk off and we put it right here. Look what our new shape is. A rectangle. So if you, well, that's why just the red part. So if you do base times height of that, still works. Cool, huh? Let me show you that again. This is why the parallelogram is the same. If you were to cut this right here, take that chunk, put it right there. Check out the shape you get. Rectangle. Because this one would be gone. It's cool. It's the same. That's why it's the same equation. So area equals base times height. That's going to take care of all your parallelograms. A square is technically a parallelogram, and so is a rectangle because opposite sides are parallel. So this is one of my favorite ones to explain. One is because it reminds me of Star Wars, and my son loves Star Wars. It's a trap.
Ow.
It's a trap. Trapezoid. You know that General, was it General Akbar?
Yeah.
He yells, "It's a trap!" The guy with the squid-looking face. And then I always think about trapezoids when I hear that. Okay, so a trapezoid has only one pair of parallel sides. Exactly one. So some of your trapezoids might look like this. I mean, there's a couple common-looking ones. Something like this. Something like this. How many sides on a trapezoid, by the way? 4. They're still quadrilaterals. But anything that has exactly one pair of parallel sides. And what's important is the bases are the parallel sides, okay? Because we're going to be referencing bases. The parallel sides are the bases. All right? Prepare to have your mind blown. I'm going to show you that this equation from parallelograms is the trapezoid equation, but it has to look a little different. I'll show you why. So let's start with this trapezoid right here. We're just going to build why it works. I can make this trapezoid into a rectangle by doing this. You ready? If I make this top a little longer and the other base a little shorter, look what I get. Do you see that? If I make that one side a little bit longer and the other side a little bit shorter, I get a rectangle, right? And you could almost imagine taking this area right here. You could flip that up into there and it'd fill it perfect. So it kind of is a rectangle. So here's what that is. If I make one side a little longer and another side a little shorter, or take two things that are different and make them the same, what's that called in math? Like adding two things together and dividing by 2. What's that called in math? Finding the what? I add them together and divide by how many there are. What is that? No, just in math in general. Like, if I got 8 on one test and 10 on another test, I got a something of 9. No. An 8 on one test? Close. An 8 on one test, a 10 on another test. 9 is my what? Average! Add two things together, divide by 2. That's the average. So if I find the average of those two bases, look what it makes, guys. Do you see that? You find the average of the two bases, it makes a rectangle. And a rectangle's area is what?
Base times.
Thank you, Samuel. Base times height. So, to get my area of the trapezoid, I'm going to average my bases. So half of my base 1 plus base 2. That's going to turn my trapezoid into a rectangle. And then I'm going to multiply by the height. That's how I memorize this, guys. I don't memorize the B1, B2, the 1/2. I know if I average my bases and multiply, it makes it into a rectangle. And a rectangle's base times height. So let me show you the visual on the other two trapezoids too, okay? So on the top trapezoid there, make that a little shorter, make that a little longer, make that a little longer, make that a little shorter. If I get the averages of those things, look what I get, guys. Rectangle. Up here, I make this a little longer, this a little shorter, look what I get. Rectangle. The equation is making it into a rectangle. It's like you're the boss of math and you're the boss of numbers and you're saying, you're a rectangle. And it can't argue with you because your math makes it into a rectangle. You're the boss. Now, you can't be the boss, Samuel, if you don't know the math, right? That's why I'm teaching you the math, so you can be the boss. All right? So this, are you guys seeing that this is making that base? Base times height. It's still base times height. All right, let's talk triangles now. How many angles in a triangle? 3. That's why it's called a triangle, right? I'm just going to write 3 sides. So, I'm going to show you a picture of a couple different triangles here. So the one on the right is a right triangle, and that has a base and height, okay? The one on the left is not a right triangle, so it has a base. But did you guys hear in that brain pop, there's a special height called the altitude? That is the height of the triangle. The height makes a right angle to the base. So you need to look for that right angle. Do you see that right angle? Let me even draw one that looks crazier. You guys ready for a real crazy one? Here's the scalene triangle. Look what the height is. The height is this imaginary line right there. The height has to be perpendicular to the base. You got to look for that right angle. And here's how I memorize a triangle. Let's say I'm going to draw the best rectangle I can. Okay, there it is. Okay? And let's say I take that what's the area of this again? Samuel knows it. He keeps telling me. What's the area of my rectangle? Thank you, Sam. Now watch what happens. If I take my rectangle and hiya! I cut it in half. I'm like a ninja. How much of my rectangle? Look what I get. I get 2 what? I get 2 triangles. And so if I only want one triangle, what do I have to do to my base times height? Divide it by 2. That's area of a triangle. I actually usually write it like this, probably because my teacher wrote it like this. But they're the same exact equation. I don't care which one you rock. No, I made that. I just karate chopped the junk out of that thing. Like Fruit Ninja.
Kia!
Oh, Kia versus Haya. I've been doing it wrong this whole time. Thank you, Samuel. I learned something today. You know, they always say teachers, good part about being a teacher is you learn new things all the time, too. So, how much of a rectangle is a triangle? So really, guys, how many equations did we... I mean, we got 3 equations today, but really, they're all the same equation, base times height. It's all about how you derive that, okay? That's how I memorize these. I don't memorize the specific letters. I memorize my triangle's half. I memorize my trapezoid. If I average my bases, I get a rectangle. So all these are rectangle equations, okay? That's how I do this thing. All right? Yeah. We're not going to mess with perimeter. I saw you guys doing perimeter really well yesterday. It's how far around something it is, right? So let's get you cracking on some problems.